Have you ever had this brilliant idea for a program, but then you sit down to actually write the code and you just freeze? Yeah, you're not alone. Figuring out how to turn a human idea into something a computer can actually understand is, honestly, one of the biggest hurdles in programming. Today, we're going to talk about the tool that bridges that exact gap. So, how do you do it, right? How do you take that spark of an idea and turn it into a real, working program without getting totally tangled up in a mess of semicolons, brackets, and all those syntax errors? It's a classic problem, and it trips up everyone, from total beginners to pros who've been doing this for years. And this slide just captures that challenge perfectly. On the left, you've got the way our brains work. It's kind of fluid, a little messy, you know? It asks questions, it worries about weird edge cases like what if the list is empty? On the right, well, that's the unforgiving world of computer code. Every single detail has to be perfect. One tiny mistake, and the whole thing comes crashing down. That gap between the two can feel absolutely massive. Okay, so let's talk about the solution. Pseudocode. The name literally means fake code, and that's exactly what it is. It's a mix of plain English and some programming-style structure. It's not a real language, you can't actually run it on a computer, but that's not the point. Its real power is something else entirely. Here's the best way to think about it. Imagine you're an architect. You wouldn't just show up to a construction site and start throwing bricks and mortar around, right? Of course not. You'd create a detailed blueprint first. Pseudocode, that is your blueprint. It's the plan you draft before you write a single line of real code. So you might be thinking, why bother with this extra step? Well, because this blueprint makes everything so much easier. It lets you focus purely on the logic, the how of your solution, without getting bogged down on all the picky syntax rules of a language. It makes it super easy to share your ideas with other people, even if they don't code in the same language as you. Best of all, it helps you find mistakes in your plan early on, which saves you hours of headaches later. And once that blueprint is solid, translating it into Python or Java or any language becomes a piece of cake. You know, every complex structure, whether it's a skyscraper or a computer program, is made from just a few fundamental building blocks. For programming, there are really only 3 core concepts you need to know. Let's take a look at the components of our blueprint. First up, we have sequence. This is the absolute most basic building block. It's just a straight line. The program runs one instruction, then the next, then the one after that, in perfect order. Just like this example for calculating simple interest. You read the numbers, you do the math, you print the result. Simple, direct, no detours. Next, we add our second building block, selection. This is where things get interesting. This is where our program gets a bit of a brain and starts making decisions. We use these really clear keywords like if, then, and else to set up a choice. If a condition is true, do one thing. If not, do something else. This fork in the road is the very heart of how programs make choices. And our third and final building block is repetition, or what programmers usually just call a loop. This is what you use when you need to do the same thing over and over and over again. Like here, where we're calculating a factorial. That for loop tells the program to repeat that multiplication step again and again until it's done. It's incredibly powerful and keeps our blueprint clean and efficient. Okay, so we've seen the building blocks. Now, let's put on our architect hat and actually draft a simple blueprint from scratch. We're going to take a really common problem and just plan out the whole solution using pseudocode. And here's our job. It's super straightforward, but it's perfect for showing how this process works. We just need to create a plan, a blueprint, that can look at 2 numbers and tell us which one is bigger. Simple as that. And here it is, our finished blueprint. Let's walk through it. We start. We read our 2 numbers. Those are our inputs. Then comes the decision, our selection block. If number 1 is greater than number 2, then we'll say the large number is number 1. Else, we'll say the large number is number 2. We wrap it up with end if. And finally, in sequence, we print the result. See how we just combined those basic building blocks to create a clear, logical plan? All right, we've designed the blueprint, we've checked the logic, and it's solid. Now it's time for the best part, the payoff. Let's see how all this planning makes the actual construction, the coding part, incredibly simple. And this is the real magic of pseudocode. Just look at this side-by-side comparison. Our pseudocode plan on the left maps almost directly, line for line, to the working Python program on the right. Read becomes input, if becomes if, print becomes print. All the logic was already solved. The hard part was done in the blueprint phase.
Writing the actual code was just a simple translation. So here's the bottom line. An algorithm is your step-by-step plan for solving a problem. It's the core idea. But pseudocode is what gives that idea structure. It's the tangible blueprint that guides you all the way from a vague concept to a finished program. So now you get it. You understand the what, the why, and the how of pseudocode. You've got the tools to be a code architect. So the only question left is, what's the first problem you're going to design a blueprint for?